Hello. Welcome to a new Rockabot class. Today we'll continue with the Python videos, where we'll see how to run a Python script, or rather an execute Python, using a pretty interesting example that will be really useful for you from now on for properly building robots. Alright, let's remember that best practices are always useful when it comes to building a robot. I say useful instead of mandatory, but the truth is that best practices should always be used in the construction of a robot. And one of those best practices is to implement logging when running a robot. Alright, what is a log? A log serves to give us a roadmap of how the robot was executed. That is, to explain to us how the robot was executed, at what moment, at what time, on what date, if any errors occurred, what they were, and if no errors occurred, whether it ran completely and correctly, and other details so that, once the execution is finished, you can read the file or search in the file to see if any errors happened or not. This helps to keep improving the robot, optimizing it in some way and, at the same time, to detect errors in its operation during execution. This is very useful in production, for example, because we might have a robot scheduled to run on a certain date, at a certain time when we might be out of the office, where we can, in some way, monitor the execution. So, when we are able to take control of the robot, we can see when it was executed, what errors occurred during that execution. So, that's what logs are for. And today we're going to work with a very important tool, which is first the knowledge or the introduction to what logs are in production robots, and then the execution of Python. Alright, let's do an initial overview of what the robot is. This robot is a mini robot that I've already built so you can see it. Notice that it's inside a try-catch. This means, first of all, that the try-catch, even though we saw it in level 1, the try-catch basically what it does is everything that's inside the try-catch. Basically, well, first explaining what the try is, everything inside the try will execute until a command throws an error, right? At that point, the try stops executing and it moves on to execute all the commands inside the catch. In other words, take a look. Let's look at a really small and simple example so you can see it. Look, here what we're doing is setting today's date with a datetime.now. Remember, we saw all of this in the level 1 course. Then what we do is open a web page. In this case it's Google's web page, in Chrome. We do a wait for object and validate that wait for object. In this case, we did a small validation where if it opens correctly, I show an alert saying it opened correctly. And if it didn't open correctly, it shows that alert and then closes the browser. This is, let's say, what happens if it runs completely and correctly. And then we have the catch, where now we're going to go step by step, but basically what it does is, in get_last_status, we get the error in a variable and then in Python, check out the script we use. Basically, what we do is save in the variable we have of type log the reference to the error. Then, we set the robot variable with the robot_name. Notice that we put it in single quotes and between %signs. And then we do the same with our variable that we already have created in our Rockbot section, message_log, where we indicate that from the error section it should save what the message says and replace the single quotes with applenader, let's say using a replace. And then set _var with a true. Here, notice that all the variables we talked about are here, like log, message, error, stop, and robot, which we'll now see how they are executed. Alright, let's go ahead and clear these variables as well. Perfect. And then we have a child robot where it will write the log. Let's go to that child robot. Sorry, I already had it open here. Here, it's the same, it's inside a try-catch, and what we do here is set the date, notice again, and then, with a save_text command, we specify a path where I want that log to be written, using a pen to create a new file. And then we have what's called fetch_log, which we can fetch a log when it runs, the type of log, the robot. Remember that we set it earlier. The name of the robot will appear, where it will describe what happened with that robot. And here we have exactly. Sorry, here in the robot field it will tell us where, meaning in which robot, and in message log, the description of that robot. So we're going to have the date, the type of log, whether it's an error or info, for example, then a dash, robot, colon, which robot it was executed on, and then the message log, what happened with that robot. Notice how easy it is to create a log. In this case, with this, we'd already have a log set up. But what happens? If we have stop set to true, we previously set the same thing, we close the browser, and we exit and stop the entire robot. In case any of these situations fail, meaning an error occurs, we do the same with a .replace, we get the error. We do the same with the .replace on the error variable. We take what it says in message and with a .replace, we replace the single quotes with nothing, and we save it back into error. So, the error message will say error message, error, and we save that at the error level so that we can set the log correctly. Alright, so if we do a little demonstration, let's first see a demo without any kind of error. We're going to run the whole robot. We can see that the Google page opens correctly. It's going to perform the object search and say it opened correctly. Perfect. It closes it there and that's perfect. Notice that the catch hasn't executed in this case. But what happens if I, for example, change this, which is an XPath, and switch it to a class? Here, there won't be a proper error from the robot itself, but rather a command won't find an element, and that's going to show up, it won't be treated as an error. I want to show you this so you can tell the difference between when something is an error and when it isn't. Notice here that the element won't be found, and it's going to show us the message that it didn't open correctly, but that means the bot itself executed properly. There wasn't a real execution error, it just didn't find an element that we told it to look for. Alright, this is so you can tell when it's actually an error. Now, how can we force that error? Look, basically, here you can see it wants to open a web page and I delete the whole HTTPS part. If I delete that part, the command won't execute properly. That command will generate an error. Since it's going to generate an error, it's going to show us that error message here, and automatically, from this point, it's going to jump to the catch part. Watch, if we run it, we'll stay here so you can see, it's going to show that this is an error. Look, here's the error. And well, it stopped here. Notice, it didn't execute any of this part and went straight to the catch section, where it writes the log and handles other things. Now, with that done, we're going to check where we saved the log, which is on the desktop, and we named it log sample. And if you look, here we have the error description, the execution, what happened. And with this, we can, in this way, create the description, or first the execution of a log, so that we can incorporate it into our robots. Remember that this is mandatory when you have a robot in production, and also how to run a script, a Python script in Rocket. Notice that with some Python command settings, like a setter, we can execute and configure everything related to a log. Obviously, this isn't the only thing you can do. You can do endless things. Everything you can do with Python will be able to run inside this window. And, of course, as long as it's compatible with the variables we've set in the robot and other related matters. And with this, we can, in a way, wrap up everything about how to configure the robot. Therefore, for us to understand everything we're seeing or have seen, these are, let's say, fundamental and mandatory tools when it comes to deploying a robot to production. Obviously, the tools that are left to see are complementary tools, but maybe when it comes to building a robot, they aren't, let's say, mandatory or required. With this, we wrap up the section on how to properly configure a robot so that it follows best practices and can be deployed to production. Alright, I hope this is helpful, and I'll see you in the next class.